For part B, we're asked to solve for the distance that the ball travels before you hear the thud of the bowling ball hitting the ground. So distance, this is our displacement. But that's when we, if we draw a picture of it, that's right here. Okay, how far did this go before it actually hit the ground? Well, we already know it fell for 0.27 seconds. What we can do is we can add that to our list, or we can leave it blank. That's fine. We have it right above. Now we're looking for our horizontal distance, so this is definitely in the x side there. Now what I want to do, I don't care about the final velocity, I do have the time, so I am going to use the exact same equation that we used up on part A. Delta x is equal to v naught t plus 1/2 at squared. All right, and I'm going to plug my numbers in there. Well, we do know our initial velocity is 6.3. And one thing I should say is, let's make this huge. I'm not using this side. Okay, I'm only using the x side here. So 6.3, and this time is good for everything. Remember, this time is so important because that could be used both in the x and the y. It's the time for this entire problem, really. Remember, we talked about the independence of dimensions. That's really what that is. The only thing that can cross over that is the time. Okay, so I'm going to add this part over here, and this should be nice because as you can see, my acceleration in the x is 0. So we don't really care, what this whole second half is because it is in fact just 0. So all we need to do now is plug this into our calculator. And look, I still have that number saved in there, but I did round, so for this one, I will go ahead and cross that out just to make sure that you are getting the same answer that I am getting. 0.27. It equals delta x is 1.703. Is it 1.70301 meters?